My name is Matthew Libera. I'm a professor in the Department of Chemical, Biomedical, and Materials Engineering. And I've been here since the end of 1989. The space that we're in right now is part of a 3,000 square foot laboratory. It's called the Laboratory for Multiscale Imaging. And in here, the primary focus is to do microscopy, to study the structure of materials. There's an array of different types of microscopes, and really the important thing that this laboratory does is twofold. One, it serves my own research interests, and I can certainly tell you a lot about that. And two, it supports a lot of other people's research interests. So the microscopes we have here are really very powerful tools. They're expensive tools, and they can be used by a lot of people here on campus. So we have folks coming here from materials, chemical engineering, biomedical engineering, chemistry, mechanical engineering, environmental engineering, all to use the microscopes that we have here, all of which are really designed to study the structure of matter, be it soil or plastics or metals or microfluidic devices or something like that. At a range of different length scales, from macroscopic to microscopic all the way down to atomic sorts of length scales. The students are involved in this lab in a couple different ways. Obviously, we do a lot of teaching, and we teach them some of the theory behind how these microscopes work, but probably more importantly, the focus of this lab is to teach people to actually use the microscopes to get results about the types of materials they're studying. So we've got students at the undergraduate level, at the graduate level, and we have folks that are staff scientists and people that come from off campus even to use these tools. So we really have students involved in a lot of different ways. One of the fun things is every summer now we've gotten a couple high school students from some of the local high schools who've been supported to work in the lab. And it's always kind of a sanity check to find out what they know and how we can influence them and learn from them, really. And one of the really nice things is, as a consequence of a couple of those students coming, I think 2 summers ago, one of them decided to apply to Stevens, was accepted to Stevens, and she's now a freshman, and she's actually got an office here in my lab and has already started doing some research with us, going through her academic program in chemical biology, but doing research here in my group, and there she's studying bacteria and how they interact with surfaces. I think one of the important things that a lot of undergraduate students in particular at Stevens, and I'm sure this is true at every university, they come on campus, they're overwhelmed with schoolwork and all the challenges that go with being undergraduates, but I don't think they understand or recognize some of the wonderful opportunities that they have to do research in this environment that we have. There's really a lot of exciting things going on in every department on different subjects. And I've really enjoyed having undergraduates do research with me. I think they blossom when they get exposed to a graduate research environment. With a little bit of patience and a little bit of effort, they can quickly establish themselves to be very independent and do very compelling research. And I see that certainly in our NERT project, just with the group of us that's working on this now. I know that all 4 of us have undergraduate research students that complement our graduate students. We're also very excited about attracting some of the best graduate students we can to work on these problems in all of the departments, the chemistry, the biomedical engineering, the materials engineering, chemical engineering. So there are really tremendous opportunities for students to get involved in these things. Having said that, I think it's important to recognize that there's a lot of the challenges that come with doing research. My experience with students, both graduate and undergraduate, is that it's really easy to get frustrated when things don't work in a clockwork fashion. And you run into a brick wall and you keep running into that brick wall. And I think one of the reasons why we call it research and not teaching is it's up to the individual's creativity and the group's creativity to find ways to get around those brick walls. And sometimes those ways take us in entirely new directions that we didn't expect or envision when we started the work. And it's those students at both levels, when they learn how to get around walls, when really the exciting part of the educational process and the technogenesis process really happens, because that's where we all really start creating. And from my point of view, that's really the exciting part, because that's when the students start teaching me. I say, wow, this is why I'm here. This is why I want to be a professor.